All right, welcome back. Problem number, oops, that's just telling me that it saved the videos. All right, problem number 9 through 10 and 11. Again, hint, the following will not be multiple choice. You are going to have to fill it in. Well, I have same base, same exponent. That means that I'm just going to perform the operation with the coefficients. So here the operation is saying add, so I'm going to do 11 plus 3, which will give me 14. Now I'm going to keep my base exponent, and I'm going to keep my base variable, and I'm going to keep my exponent. So my answer is going to be 14t to the 4th power. That's my answer, and that's what you would box and circle. Number 10, we're going to do the same way. We have same base, same exponent. So we're just going to perform the operation with the coefficients. So I'm going to take 30 minus 12. Which will give me 18. I'm going to keep my variable v, and it's going to keep my exponent 4th, and then w, keep that variable, and then keep my exponent to the 3rd power. Now here you're going to do a little extra work. We have to distribute that -1 to both terms inside the parentheses. So I'm going to rewrite this as 14h squared plus 3h minus 9h squared. Minus times a positive become a minus 2h. Now I'm going to simplify. I can combine like terms, so I can combine these two here. Let me do a highlighter. I can combine 14h and -9. So that's going to become 5h squared. And then I can combine 3h and -2h. So that's going to become positive h. Okay? Problem 19, or not, problem 12 and 13, we need to find the special two binomial factors of 12 through 13. So that means as soon as we know that we're talking about special, that means that we're going to be talking about those special rules. Number 12, I see that it's a negative value, it's a binomial, and I see that my two values here, my a and b value, my first two terms, are perfect squares. So I automatically know that that looks like my perfect square of a product of a sum and a difference. If I have a squared minus b squared, that's going to be equal to a minus b times a plus b. So here, my a value is equal to 3x, and my b value is equal to 10. So now I can rewrite this as 3x minus 10 times 3x plus 10. Okay? Number 13. Now, there's also another perfect square, or another special case of binomial factors and factoring. Okay? That special case is when we have a plus b, and that a plus b is squared, or we have a minus b, and that case is squared. Again, I will give you both of those formulas on the test. On this one, we're going to happen to be that one. That's going to be equal to a squared minus 2 times a times b plus b squared. It's actually just like we did with problem number 8. It's just in this case here we had a plus b. Here we have a minus b. So now I'm going to take my a value. My a value is v. So that's going to be, let me do a different color. So then that's going to be v squared minus 2 times my a value, which is v, times my b value, which is, in this case, 36. That's going to become 6. So my b value is equal to 6. So then that's going to be 2 times v times 6 plus my b value, which is 36, or 6 squared. Okay, that's going to be equal to v minus 6 squared. So as you can see, this is our answer for the two factors. But as you can see, as I go backwards, this is my check. Let me write that. I did my check first. All right, so then that's going to be v squared minus 12v plus 36. 6. All right, but that's what you're going to put as your answer because these are the factors. V minus 6 is the two factors because that's the same thing as saying V minus 6 times V minus 6 because that square value means that that's that binomial twice. Problem number 14. Let me enter down so that I have more room. All right. Problem number 14. If I notice that, well, that is a perfect square because it's squared. So I'm going to do just like what I did up here in this problem. And this problem up here, I'm going to do just like what I did. So I'm going to say my A value is equal to 5t. My B value is equal to 4. So I'm going to say 5t squared plus 2 times my A value, which is 5t, times, and we're simplifying this. So that means when we're simplifying, we're going to the trinomial. That's how you can tell the difference between the two of them. Times my B value, which is going to be 4. Okay? Plus my B value again, which is going to be 4 squared. Now I'm going to simplify all this. This needs to be distributed to both terms, so that's going to be 25t squared plus 2 times 5 is 10, times 4 is 40t plus 16. Problem number 15. I'm going to just erase that just so that I have a lot of extra room. All right, problem number 15. I notice that this is a plus and that's a minus. If my A value, if these first two terms are the same, and then these second two terms are the same, then I know that I'm using this special case rule here. Okay? So this is going to be the A squared minus B squared. So now I can say that my A value is equal to 4x squared and my B value is equal to 7y. So when I write this out in my rule, this is going to be 4x squared squared minus 7y squared. So then that 2 gets distributed again, so that's going to be 16x to the 4th power minus 49y squared. Okay? And in terms of talking about going back to check this, if I were to check this, okay, my check. Remember, I said that we take our value here, our A value, that's squared, minus our B value, that's squared. So then that's going to be equal to A minus B times A plus B. So then my A value is going to be 4. My A is equal to 4x. The square root of 4 is going to be 2. And then 49 is going to be 7. And then y squared is going to be y. So then that's going to be 4x squared minus 7y times 4x squared plus 7y. That checks with my original value. The order doesn't matter. I have when I checked it, I put the negative first. That's okay. But this here is going to be your answer for the test. All right, that's the end of the common assessment. I will see you later.